Hello, here are the 6.1 video notes for us to work through together so that we can work on homework in class. We have talked about, you guys already, perfect squares, numbers whose square roots are integers. So perfect squares are numbers like 1, 4, 9, 16, etc. And we've talked about perfect cubes, numbers like 1, 8, 27, 64, etc. We've done the stuff with the perfect cubes in particular in the last unit where we did the sum and difference of cubes and we had to factor. But it's important that these start to become really recognizable to us. And not only things that are raised to the second and the third power, but also raised to the fourth and the fifth power and the sixth power. And so you guys have this table of powers you should recognize. And I'd like you guys to fill that table in. So I'd like you to press pause and just fill in what is, 1 squared cubed to the fourth, to the fifth, to the sixth. What is 4 to the second, to the third, to the fourth, to the fifth. And these numbers that you're going to be seeing in this are numbers that we are going to need to recognize in order to move forward. So please press pause and fill in that chart. Overall, this is what that chart should end up looking like over time. And we're going to use that when we find the nth root of a. For an integer n greater than 1, if b to the n equals a, then b is considered to be an nth root of a. We're also going to define an index of a radical. An nth root of a is written as like the square root of a with a little n here, and n is called the index of the radical. When we have the square root, we don't, there's really a little 2 that's here when we write the square root, but we don't generally write it because square roots are so common. But in general, what has to happen is when you have the index of a radical, when we talk about the index, it's this little number here, and that's the root that we're taking of a. So just some notes about the real nth roots of a. Let's say that you're taking an nth root, and n is an integer, so, but we're going to have it be greater than 1, and then a is going to be any real number. So if n is an even integer, like when we take the square root, you know how we always use plus or minus the value when we took the square root? We're going to do that for any even integer. So if a is less than 0, this ends up having no real nth roots. So for example, let's say that you had b to the fourth equals negative 16. To solve that equation, to get rid of the 4, what you would do is you would take the fourth root of each side. And so we'd have the plus or minus, but the fourth root of negative 16, we can't do it because you can't take the even root of a negative number. So we say in this case that this has no real roots. But let's say that a was 0, which means that we're trying to take an even root of 0. Well, what we would do is we would take plus or minus the square root of 0, but 0 is a neutral number, so really we just get one real nth root, which is 0. And then if we have a is greater than 0, then what we'll do is, so for example, let's say we had b to the fourth equals positive 16. Again, we would take the fourth root of 16. And what we do in the chart is we look at the chart and we look at 16, and we look under the fourth, and we find 16, and the fourth root of 16 is 2. That's kind of how you'd use that chart. And we see that we have 2 real nth roots. Notice we have plus 2 and minus 2. So if it's an even integer, let's always use that plus or minus, but remember that we can't ever take the even root of a negative number. Now, if it's odd, it's a little easier. There's only one real root each time, and let's look at why that is. Let's say that we have b cubed equals negative 8. To solve that, we would say we would just take the cube root of negative 8. with odd roots, we don't need the plus or minus. We just have one of them. And so when we take the cube root of -8, we just have -2. When you think about it, -2 times -2 times -2 will give me -8. If I use +2, that wouldn't give me -8. The same would be true if you have like b cubed equals 0. We would take the cube root of 0, which is just 0, again, 1 real nth root. And if we had a positive number that we were taking the odd root of, like we were taking the cube root of 8, again, 8 only has one cube root, which is 2. -2 wouldn't work. Multiplying -2 by itself would give us -8. So we're all set. So in these problems, when it says to find the indicated real nth roots of A, what I want you guys to do in these problems is to make sure that you write it as an equation first, because they're asking you conceptually how many nth roots would that number have. So don't just start by taking the cube root of 64, start by writing it as an equation. So in letter A, if I have n equals 3 and A equals -64, we're going to put that into this equation right here, that b to the nth equals A. And so I would kind of think about that as b to the third equals -64. Then what you would do is you would think about taking the cube root of -64. Because it's odd, we only have one root. And so then we would end up with -4. So our answer is -4. In letter B, if n is 6, that means that we would think about our exponent being 6. And we're going to think about solving b to the 6 equals 729. To do that, what we would do is we would take plus or minus, because it's even, the 6th root of 729. And again, what we could do is look on our chart. We look under n to the 6 and 729, and we see that the 6th root of 729 is 3. So we would say that our answer is not just 3, but because it was an even root, we would say plus or minus 3. In letter C, we would think about this as b to the 4th equals 0. We would then take the 4th root of each side, and we'd use plus or minus because it's 0. Or sorry, because it's an even root. But when we evaluate that, we just get 0. We don't want to put plus or minus 0 on there. That would be silly, since 0 is neutral, so it's just 0. And in letter D, we would think about this as b cubed equals 512. So that means that we would want to take the cube root of 512. We don't need the plus or minus because it's an odd root. And then what I would do is on my chart, I would look at 512 under the cube root. Sorry. You would look under 512 under things that are to the 3rd power, and we can see that the cube root would be 8. And so we would end up then with b equals 8. No plus or minus because it's an odd root. So basically, when you're finding the indicated real nth roots, you can use the chart to kind of help you out, but think about what the solution to that corresponding equation could be. Notice I didn't write my answers as equations. Oh, I did here. I didn't mean to. Sorry. Because they were just asking for the nth roots. There wasn't an equation to solve. So all we would want to do is have that final answer is 8. That's it. Okay? So now let's talk about rational exponents. And this is kind of the heart of that section. One thing that I want us to realize that if you have a raised to a fractional power, so like a to the m over n, that's really the same as a to the 1 over n times n. And so remember when we talked about properties of exponents, if you have a power raised to a power, then you're really multiplying them together. And isn't 1 over n times m, isn't that the same as m over n? So it's really just kind of using that property backwards. And the reason we would do that is because we can rewrite a to the 1 over n as a radical. So when you see a to the 1 over n, what that really is doing is you're really taking the nth root of a. And then we can think about this using nth roots to help us solve or even simplify expressions that involve fractional exponents. So basically, I want you to notice that the denominator of the exponent becomes the index of the radical. Okay? So that being said, if we have a to the 1 over n to the m, that's really like saying I'm going to take the nth root of a and raise it to the mth power. Okay? We'll practice that in a minute. If you have a negative exponent, the same thing will happen. But remember, negative exponents, we have to move it across the fraction bar. So if I had a negative exponent, I'd move it to the denominator. Think about breaking it down the same way so that I could use the nth root of a and raise that to the mth power. So here's how you would put that into action. Let's say that you had negative 125 raised to the negative 2/3. Well, first of all, we'd get rid of that negative exponent by moving the negative 125 to the 2/3 to the denominator. Notice this stays negative. It's the exponent that changes sign. Okay? So what that really means is that the denominator of the exponent becomes the index of the radical. So this really means I'm taking the cube root of 125 and squaring it. So again, the denominator of the exponent becomes the index of the radical. And then that's something that we're able to evaluate. Use your table of powers and let's find what is the cube root of negative 125. Well, we can see that the cube root of 125 is 5. And if we take the odd root of the negative number, it's going to be negative. So we would have 1 over negative 5 squared, which is 1/25. And that's how we would use that to simplify these expressions that involve rational exponents. Rational meaning fractional exponents, basically, as far as you guys would be concerned. So let's practice that here. We're going to evaluate an expression with rational exponents. Notice this is a non-calculator piece, which means that you're going to need to know and be able to recognize these powers come quiz test time. So this is 64 to the negative 1/6. Well, let's start by writing that as 1 over 64 to the 1/6. Now let's rewrite this as a radical so I can take a certain root. Since it's to the 1/6, that really means that I'm taking the 6th root of 64, and then the numerator was 1, so that goes here. So now I want to evaluate what is the 6th root of 64. Using my chart, the 6th root of 64 ends up being 2. 2 to the first is 2. So then my final answer is 1/2. Let's say I was to try to evaluate 9 to the 3/2. Again, this means that my index is really going to be 2. So I have the square root of 9, and then the numerator is the exponent that I raise it to. And technically, whenever you have the square root, you don't have to write it. So that's a fine way to rewrite. And we know that the square root of 9 is 3. And we know that 3 cubed is 27. So 9 to the 3/2 is 27. 16 to the negative 1/4. I would start by thinking about that as 1 over 16 to the positive 1/4. Then I would think about it as 1 over the 4th root of 16. Since 4 is my denominator of the exponent, that's going to be the index of my radical. So the 4th root of 16 to the first goes in the denominator. The 4th root of 16, using my chart, is 2. And then again, 2 to the first power is just 2, so my final answer is 1/2. 36 to the 3/2, that means I'm going to be taking the square root of 36. And I don't need to write that index of 2, and then I'd cube it. So that's really going to give me 6 cubed, which is 216. And as you're doing these in the homework, you are probably going to start by using the chart. But at the end of these next couple lessons, the hope is that you are going to be able to recognize it and move away from the chart at all, because you won't be able to use that on the quiz. So take a second and pause. I know some of you won't, but I'm asking you to pause and try these your turns on your own. And then when you're set, you can check out what the worked out solutions are. So please press pause. You can check your answer to number 1. Number 2. And number 3. So 1 over 16, your turn 1. The answer to number 2 is 1, and the answer to number 3 should be 9. And that's the work that hopefully you have. Now, let's say we tried that in example 3. We could rewrite this as the cube root of 10, and we look on the chart and we're like, it's not in there. So what that means is that 10 isn't a perfect cube, so we can use our calculators. My suggestion to you, especially if you have an old operating system, is you're just going to use, again, just put it in the calculator. Some of you guys might have to put fractional exponents in parentheses. So if you have the old operating system and you were doing letter A, okay, sorry about the glare here, is that better? So if you were doing letter A, you would do 10, and then you would press the caret key, and then just make sure if you have this operating system that you put the 1/3 in parentheses so you can evaluate. It asks us to round to the nearest hundredth or 2 decimal places, so that would give us 2.15. If you have a newer operating system, what'll happen is that it'll be elevated here. In that case, you don't need to use the parentheses. You can if you want. It'll give you the same thing. But I just want to say if you have this operating system where the caret shows up, you definitely need to put the 1/3 in parentheses. So we've just agreed that that's going to be about 2.15. We could do the same thing for 21 to the negative 1/4. Just put in parentheses negative 1/4, or in the other one, just put as your exponent negative 1/4. To the nearest hundredth, this would round to 0.47. And the thing is that I know there's a root key on your calculator. Like, I get it, okay? Like, I teach math, I know this, okay? I know that there's a place in the math button that you can take an x root. So I know that you can do, you know, the 6th root, what do we take the 6th root of 13, and you can get the answer this way. But I think that's a little cumbersome, to be honest with you. I think that it's much easier for these problems to use exponents, because what would the 6th root of 13 be? Isn't this really the same as 13 to the 1/6? So instead of doing all this math stuff and trying to remember where it is, I think it's going to be easier for you if you just recognize that the 6th root of 13 is the same as 13 to the 1/6, okay? And yes, you get the same answer each time. Notice it's the same. We get about 1.53. But I think that this is actually more steps, and I think it looks silly, especially in the old operating system. So anyway, so your value here is going to be about 1.53. So I would do the same thing in letter D. Instead of taking the 4th root of 80 to the negative 2, I would rewrite that as 80 to the negative 2/4, which I guess would be the same as negative 1/2, right? So regardless, we could just put it in the calculator, write that. We could put 80 to the negative 2/4, and that gives us about 0.11. So that's my suggestion. I know you can do it in the calculator another way, but I really think it's easier to use those exponents. Okay, So now we're going to actually solve some equations. When we're solving an equation, x to the, let me show you what this is. To solve an equation, x to the n equals a, you're going to take the nth root of both sides, or what you could do is you could raise both sides to the 1 over n power. That's essentially what you're doing and why it's legal to take that root. So this asks us to solve the equation and when necessary round to the nearest hundredth. One thing is to make sure that that you isolate the power. In letter A, I can't tell you how many people start by taking the sixth root of both sides, and that's such a bad plan, you guys, because we need to get rid of that 2 first. So make sure that you isolate the x to the n part first before you start rooting things. So I would start by dividing both sides by 2, and we get x to the 6th equals 729. So to solve that, we would take the 6th root of both sides, essentially. And because it's an even root, remember, what should we do? Plus or minus. So essentially, we end up with x equals plus or minus, the 6th root of 729. And then we can look in our chart at this point if we don't recognize it, and we can see that 729 is something that we can take the 6th root of evenly, and it's 3. So our answer is plus or minus 3. Let's look at letter B. Notice that we don't have anything on the outside that's being multiplied by that quantity to the 4th, nothing being added or subtracted. So in this case, we can start right away. Again, this is an even index, so I'm going to take the 4th root to get rid of it, and because it's an even index, I'm going to use plus or minus. This cancels, and I get just x to the 8th, and I have plus or minus the 4th root of 2. Well, that's not something we can do, so let's just leave it as the 4th root of 2. I know it says to round. I'm not going to do that till the end, you guys. So I'm going to isolate x, and I need to do that by subtracting 8. And so I get x is negative 8 plus or minus the 4th root of 2. Now, I like that answer, but it did say to round to the nearest hundredth. So what I might do in my calculator is enter negative 8 plus, and instead of the 4th root of 2, that's really 2 to the 1/4. And then remember, I'd also have to find negative 8 minus 2 to the 1/4. So you can just put that in the calculator, negative 8 plus 2 to the 1/4, and we get about negative 6.81. Negative 8 minus 2 to the 1/4, and that gives us about negative 9.19, okay? So that's how I would type those in. So again, negative 6.81, negative 9.19. So if it doesn't work out evenly, that's when you use the calculator. In letter C, notice that we have an extra 9 here, so I'm going to get rid of that by adding 9 to each side, and I get x cubed equals 40. Okay. And notice that because this is an odd root, I won't need the plus or minus when I take the cube root of each side. So I'm just going to take the cube root of 40, and 40 doesn't have a cube root that is rational. So I can put that in my calculator as 40 raised to the 1/3, and I get about 3.42. Okay, so problems like A would be on like a non-calculator part because you're able to do that without a calculator, but clearly B and C would be problems that would be on the calculator part. And I know that's a big number to divide. Again, we'll try to make it not that, like numbers not that big on the calculator part, okay? Or on the non-calculator part. Okay, example 5. This just says the population P of a certain animal species after T months can be modeled by this equation. P equals C times 1.21 to the T over 3, where C is the initial population. I want you to find the population after 19 months if the initial population was 75. Well, don't go like this. All this is saying, this 19 months is saying that T is 19 And this population of 75 is just saying that C equals 75. So let's just put that in. So we'll say P equals 75 times 1.21 to the 19 over 3. So why don't we just put that in our calculator, all right? So let's take 75 times 1.21, and let's raise that to the 19/3. That's all this problem is asking you to do, you guys. And so it says 250.82. And this is looking at the population of animals. It's not measured in thousands or millions, so I'm going to round that to about 251 animals. I'm going to round up. Okay? So notice sometimes words aren't really scary, it's just asking you to put things in. And then in example 6, the volume of a beach ball can be approximated by using V equals 4/3 pi r cubed, since that's the volume of a sphere. R is the radius of the ball in inches. It wants us to estimate the radius if the volume is 382 cubic inches. So let's put 382 in for V. So we would say 382 equals 4/3 pi r cubed. We might want to get rid of the 4/3 first by multiplying everything by 3/4 by the reciprocal. That would give us 286.5 equals pi r cubed. Then we might want to divide by pi, because remember our goal is to get your power all by itself. And this is about, if I put 286.5 divided by pi, that gives me about 91.196. But I'm going to leave that in the calculator, and really if I want to get rid of this, I'm taking the cube root, which is really raising it to the 1/3. So what I could do is I could take that answer and raise it to the 1/3 power, and I can see that my R is about 4.5, and that was measured in inches. Okay. You also could have taken the cube root of the answer. I know that in there's a cute little cube root thing, whatever, floats your boat. I'm just trying to give you something that you can use always instead of just some of the time, okay? So if you were confused, you guys, we'll work through stuff in class tomorrow, I promise, well, Monday, or whatever day we end up doing this, and that should be it. So have a good day. We'll see you guys soon. Bye.